Okay, so now we're moving on to a new method for apportionment called the Huntington Hill method. And, okay, the method is you take your population, whatever it is, and then you square it. And then you're going to divide that by the number of representatives times the number of representatives plus one more. And when you do this calculation, that's what they call the Huntington Hill number. And they wrote it all down here, which I'll highlight in a bright green. That's the formula for calculating what they call a Huntington Hill number. You take your population and you square it, and then you divide it by the number of representatives that they currently have, that is your X, times one more. So if your current representation is 6, then you're going to multiply that times 6 plus 1, which will be 6 times 7. So if your current representation is 12, you're going to multiply that times 13, because that's 12 plus 1. Now, you have to do it for 2 different states. And let me erase this big circle thing. They take the population of one of their states, which they call Y, and they take the population of the other state, which they call, let's see, what color have I not used? This one. This one, population of X squared divided by X, little x times X plus 1. And they put a less than sign here. If the first one is less than the second one, it's the second one that would be given it. Okay, if states X and Y have already been allotted X and Y representatives, respectively, then state X should be given an additional representative in preference to state Y, provided that Y's Huntington Hill number is less than X's Huntington Hill number. Now that's how they state it, but I always remember that the larger Huntington Hill number, which I call the HH pound sign, a pound sign. Okay, you guys probably call it a hashtag, but to me it's a pound sign on a phone. It's also called, it's the symbol we use for number, and it's also a little thing we use to play tic-tac-toe. But this guy right here, I use that to represent number. So HH number, Huntington Hill number. The larger Huntington Hill number will get the next seat. Okay? This is when you're going to add an extra number. And I just realized I wrote that down here, so I really didn't need to write all that. Whichever state has the larger Huntington Hill number gets the next seat. All right, let's look at an example. All right, there are 320 full-time nurses and 148 part-time nurses at some hospital. And the nursing supervisor has already chosen 4 full-time nurses and 2 part-time nurses to serve on a committee. Use the Huntington Hill apportionment principle to decide whether a 7th nurse put on the committee should be either full-time or part-time. So right now they got 4 full, 2 part, that's 6 nurses altogether on this committee. And maybe they've gotten more and more things to be assigned to do on this committee, and they're like, we need help, we need help. We need a 7th nurse to help us out. Okay, who should it be? Should it be another full-time one or one of the part-timers? So we're going to compare the Huntington Hill numbers. And so I did the full-time in purple. There were 320 full-time nurses, right? So I did not do that in purple. I did part-time in purple, sorry. 148 part-time nurses, right? There it is, 148 squared. And there's currently 2 part-time nurses. There's the 2 in the denominator. Times 1 more than 2 would be 3. So take 148 squared and divide it by 2 times 3, that's 6. And you get this number right here. So that's their Huntington Hill number. I then am going to go to the full-time nurses, which looks like a reddish color, but that's going to be too dark, so I'll just use pink. There were 320 full-time nurses. There's the 320. You square it, and they already had 4 full-time nurses on the committee, so there's the 4, and you'll multiply it times 5, because that would be 1 more nurse. So 320 squared divided by, well, 4 times 5 is 20, and you get this number. Whichever one of these is the larger Huntington Hill number gets it. The 5,120 is greater than the 3,621, and so therefore it should be a full-time nurse. Therefore, the next nurse selected should be a full-time nurse. Now, if there had been an 8th one, maybe they just kept going and more stuff was being asked of this committee, and they're like, oh my God, what? We need another one. Now they're up to 8. This Huntington Hill number in the purple wouldn't change because they still only have 2 nurses. But you'd have to recalculate this Huntington Hill number, but with the denominator of now 5 times 6, because now they have 5. And then compare those 2 numbers. And that's how that works. So what do we got here? I'm going to do a separate video for this one.